Good morning, everyone, and welcome to the Cloud Lunch and Learn Kickoff Ideathon Day. My name is João. I'll be the moderator for the first two morning sessions. So let's get this started with introduction to the Ideathon session that will be presented by Hugo, Victor, and Evelyn. So over to you guys.
Hello, everyone, and welcome to the Cloud Lunch and Learn Ideathon. Give me just a sec here, please. Sorry. Okay. Again, hello, everyone, and welcome to the Cloud Lunch and Learn Ideathon. My name is Hugo Barona, and I'm a Cloud Solutions Architect and one of the members of the fantastic team of the Cloud Lunch and Learn. And I have Victor with me to introduce and explain to you what is the Ideathon. Hi, Victor. How are you doing?
I'm very good, Hugo. What about you?
All good. Thank you.
Good. So, for those who don't know me, my name is Victor Rodriguez. I'm cloud specialist at Storm Technology, and I'm active member and proud member of the Cloud and Lunch and Learn, where my sessions are more related to IoT. I would like to welcome everyone to the Cloud Lunch and Learn Ideathon, and hope you guys can enjoy all sessions. So, Hugo, tell me, what is the Ideathon? What's the idea about this?
Yeah. So essentially, Cloud Lunch and Learn Ideathon is a new concept that we are introducing in the Cloud Lunch and Learn, and to enable the community to apply their skills and knowledge to design cloud solutions to solve complex real-world challenge. Also, you work as a team while connecting and working with the community, including your friends, family, and work colleagues. So most of the time, the online challenge you have available require you to implement the solution your team is proposing. And the implementation phase takes most of the time of the challenge and requires people to know how to code and implement solutions. So we thought about creating the Ideathon focused only on the design of cloud solutions to be more inclusive and enable anyone, including non-developers and non-tech people, to participate and work as a team to design the solutions. Also, this concept is an extension of the Cloud Lunch and Learn model. So as you may know, we have been delivering Cloud Lunch and Learn sessions to the community, so anyone can attend those sessions and learn about the clouds and obtain all the knowledge about the cloud service and tools available. So with the introduction of the Ideathon, anyone can participate in the challenge and apply their knowledge and skills to solve the challenge.
Hugo, it's amazing the work that Cloud and Lunch and Learning is doing right now. And the Ideathon, it's just the beginning of what we can offer to the community. So this event is composed for two phases, or we can call this 2 days actually. The first phase starts today with a full day of sessions about building solutions in the cloud. So the second phase is the Ideathon Day on October 24. And it's a full day dedicated to the challenge where the participants will work with their teams to design the solution to solve on the revealed challenge. So before we talk about what's expect on the day of the Ideathon, I would like to highlight how the sessions today will help you to prepare for the Ideathon and other scenarios that require, let's say, around the design solutions. Uh, our first session today will be with Ishan. Ishan is a cloud solution architect for data and AI at Microsoft, where he's going to cover the application design and integration. So followed by Martin. Martin is a senior Azure consultant at Ensono, where he's going to cover business continuity, performance, and availability. And you cannot forget about security and compliance. This subject will be covered by Sasha. He as well is a cloud solution architect at Microsoft. And after that, to help understand resource and cost optimization, Derek Smith is senior technical consultant at Ahead. I can't wait to connect to these sessions and leverage my knowledge around the subject that for sure will help us on the real world challenge and during the Ideathon Day.
Yeah, definitely, Vitor. And after you attend the sessions today, you can sign up to the challenge and be ready for the Ideathon Day. So the Ideathon Day will be a full day dedicated to the challenge, We will kick off at 9:30 a.m. Greenwich time zone with an introduction where we explain the rules and guidelines of the challenge. And we will have Evelyn with us explaining all the details of the challenge itself. Each participant will have its team and we'll work with them to design the solution. Also, we will have a coach per team that will provide you some guidance and help your team design the solution while attending the requirements of the challenge. So concerning to the sign up, we will be opening the sign up today. It's a simple form that you can submit to participate in the challenge. You can submit an individual registration or a team registration in case you already have your team. But note that teams may change in terms of its members, since each individual signing up to the challenge will be assigned to an existing team. All the information about the sign up can be accessed on the events page. So www.cloudlunchlearn.com/Ideathon. And each team is composed of at least 3 people and at most 5 people. And please note that there are a limited place available for the signups, so we'll follow a first come, first serve system.
So I can't wait for this to go. I'm really amazed about everything. So for today, we have here the lovely and special person. She's a senior software developer. She's a PhD fellow at the Trinity College and an amazing mentor. Welcome, Evelyn.
Thank you very much. Appreciate it.
Evelyn, I can say that every time we met, I feel motivated to do something new. Can you tell a little bit about yourself and the work you have been doing?
Absolutely. So thank you so much, first of all, for inviting me and having the project that I want to talk about as one of your, as a matter of fact, I'm excited that it is the first of many to come for yourself. So thank you so much for that. So like you rightly said, my name is Evelyn Nomayo. I am the founder of a company called Phase Innovate. And what we do there, we're more or less a non-for-profit organization that strives to bridge the gap between gender and race gap in technology, or in the tech field, so to speak. We do this by actually mentoring and training people from the underrepresented community to become technology experts or entrepreneurs. So that's what the company I represent, that's what we do. At the same time, I'm a PhD student in Trinity College. My PhD focuses on IoMT, that is Internet of Medical Things, and with a focus on latency reduction. So that's about who I am.
That's amazing, Evelyn. So many things are doing right now. So tell me a little bit, to give like a small flavor of the app that you developed like a couple months ago. Can you do some presentation about it?
Absolutely. Absolutely. But I think it's good to put the app in a context, before we start, I start talking about the challenges. Exactly. So on a yearly basis, I would normally mentor women, young girls, to solve social problems using technology. So this specific project that I'm, bringing to the community to look at is, I'll say, it's an award-winning app, that was presented by myself and 3 other young girls, and that participated in a global competition called Technovation Girls. And I presented 6 teams, and 4 of the teams got to the semifinals. And the number of the teams that participated in this competition, there were over 1,500. So, but I'm lucky enough, my team won the competition. And this is what we are presenting today, which is called, the name of the app is called Memory Heaven. And the idea behind the app is to see how we can support people that live with dementia, that have problems with challenging memory losses. That's the idea behind the app.
That's very good. It's amazing. I'm looking forward to see more details about this and how can Ideathon you can help, like even like on a small piece of the challenge that we're having right now. So
Yeah.
yeah, it's amazing. I'm really excited about this. Thank you for that.
Yeah, super. So if you don't mind having my slide on screen, just so I can just quickly talk through what it is. I won't take too much of your time.
Let's go.
Yeah. So basically, if you want to move on to the next slide, that is me there. I've already introduced myself. Can you see the slide?
Yes, we can see your screen. If you want to just put
Yes.
the presentation mode,
Okay.
you can just jump
Yeah.
this slide
I think
first.
you have to do that from there. Do I have
No,
access?
you can do. No, you do yourself. Yeah.
Oh, can I do it myself?
Yeah.
Oh, super. Right. I didn't know. I thought you would handle everything. Right. So that's it there. Can you see it?
Yeah.
Yes, all good.
Right, and I can grab my stuff there. So that's me there. I have introduced myself already. So I will just move on to my next slide. So, and like I said, that's the user interface of the app. Memory Haven basically was created to support and promote the independence of people that live with dementia, that have challenging memory losses. And the idea is to be able to connect them with their friends, have easy access to medical practitioners, have easy access to emergency contacts, and so on and so forth. But the whole idea is to make the people that live with Alzheimer's disease to feel comfortable while they're living with it. That's the idea behind it. So yes, this is the user interface, and these are some of the major the main features of the app. Right.
Okay.
So we have two basic challenges, but let me just start up with some, give a reason why one will actually have to focus on looking at this challenge. If I can call some statistics, according to Interpol reports, since the pandemic, about 22%, there's been an increase in malicious domain, 33% increase in malware, ransom. I can go on and on. There's a lot of hacking going around because of pandemic, because a lot of people are making use of technology now. And one thing that's so critical now, it's what we call identity authentication. So one of the challenges that we'll be looking at, the main challenge is how can we create a platform that will make sure that vulnerable adults that will be using this application will not be scared that their data will be stolen. So basically we have two challenges, the technical challenge and the ethical challenge. So let me just quickly go through what the technical challenge is. Like I said already, identity authentication will be one of the main issues that we want to solve. We want the users to feel very safe when they are using the application. And of course, one of the features will be videos. They want to be able to extract videos and music from APIs. Do you get it? So that would be one of the challenge. What's the best one to use? Suggestion of the best APIs that we can seamlessly integrate into the app. Then at the same time, we want to be able to capture and identify a person, because one of the things that people that live with dementia or that have problems with their memory is that they have difficulty recognizing people. So what sort of application or what sort of architecture that can we design that can discreetly identify somebody, capture a relative that we can impute into the app, and at the same time identify this relative when the relative comes, But listen, if this is not clear enough, I'm open to more questions, but that's the idea behind that. Then again, the fourth one we'll be looking at will be suggestion on secured, low latency and reliable technology that can be used for making video calls. Again, we want to make our users to be very comfortable, to be able to make calls from the app easily, calls to their relatives, calls to doctors, calls to whoever they want to make call with videos. So what's the best technology can we use that will be seamless and at the same time fast I mentioned low latency because I know with videos, there are usually some lags and here and there. So that's a challenge that we are hoping that the community will be able to help us. And finally, for the technology aspect, it will be different alternative methods to capture vital signs. We want the users to be able to automatically send their data to their doctors. The app has that functionality as well, So we're looking at maybe IoT wearables. What's the best IoT wearables that can seamlessly transfer data from the device itself and straight to the app? So that's the challenge. And things that we're looking to capture will be things like respiration, pulse rate, pressure, blood pressure, and body temperature, and so on and so forth. So these are the technical challenges that we are hoping that the community can come up with lovely suggestions and see how we can integrate it into the system. And the last one, of course, and the very important one, is the ethical challenge. This is so important because we are going to be dealing with vulnerable adults. For somebody that has challenging memory losses, they're vulnerable people. So we want to make sure we cover things that has to do with ethics. There's an AI element in the application as well. We want, how do we deal with informed consent to use? How do we deal with that? How do we deal with safety and transparency? How do we deal with algorithmic fairness and biases and data privacy? So these are our challenges. And we're hoping that the community can come up with something very fantastic for us. I guess that's about it. Thank you so much. So you can stop sharing now. Thank you.
Thank you, Evelyn. That's amazing. I think the community can come up with a couple of ideas. And when we talk about the Ideathon, it's not to come just with it, like misplaced ideas here. I have an idea there. I can fix your problem with that. But a well-structured idea that can help it, like memory heaven and yourself as a business. Like when we take care about what will be the design of the solution, what will be the cost structure, what will be the partners that memory heaven can have as making the B2C business. Yes. So what will be the value proposition? So what will be the channels that the app can communicate? What will be, let's say, the revenue stream? So you'll be app open to the community, but at the same time need to keep the costs tight to be able to build more and more and more and more. So Ideathon, the main idea of the Ideathon is come with all these questions, all these challenges behind the scenes that happen, not just, okay, we can just implement this small service here, and you can do a piece of code here, and that's it. But what will be the overall deliverable, what to be able to deliver a solution? Not forget about it, of course, the ethics behind of this, so the data privacy, data security, so, and not forget about the person that is using, so the vulnerable person, so that kind of thing. So Ideathon, I think, you'll be an amazing place to start with, to brainstorm around this idea. And I'm looking forward to on 24 to have the participants having great ideas, and we can really observe the side of memory heaven.
Absolutely. That's spot on. Yeah, exactly. I like the word you used there, in totality. Yes, I did. I just talked about basically the technical and the ethical challenges. Of course, there's the business challenge as well. Exactly. Like you rightly said. Thank you very much for that.
Yeah. So yeah, that's the main thing with the Ideathon. The main is design the solution. And you cannot think about design solution not just in aspect of the infrastructure side of, let's say, if I'm going to implement this in a cloud vendor, or we're going to use this kind of code, but as well as a business. So that's why the main idea of the Ideathon is not just bringing technical persons, but persons that have knowledge around the field. So project managers are well invited, business analysts, data analysts, medicals, because the specific case of the next challenge will be related to this. So people that have some knowledge, it can provide, let's say, good insights on this brainstorm.
Absolutely. Yeah.
And I would like to add something on this. Definitely, see, this is basically a good opportunity for the people that have been following us and attending our cloud sessions and learning about the cloud as well. So they have the opportunity now to work as a team and apply their knowledge and skills and basically do something productive with all the knowledge they are getting from all the sessions they have been attending. And definitely it's a real good challenge for the community and good opportunity for the community to join us and apply their knowledge and skills. And develop these kind of solutions to solve real world problems,
Yeah, I would like to add something more here, that everyone's invited to this challenge. It's not independent of the level, if you're at the senior level or medium level or junior level or just an intern or just a student. So everyone are welcome here, because we can produce a lot of things when we work together, work as a group. So when you start to think about around a solution, we can produce a lot of good solutions just to start. And that's the main thing with the Cloud and Lunch and Learn. And that's the main thing with Cloud and Lunch and Learn Ideathon, is to connect the different levels and how we can share and care about each other on this main thing.
And if I may add this to it as well, I know typically, maybe people like medical practitioners, they may not be in this field, but they can also, if you have relatives that in that space, they could also contribute to this as well, because that's their area of expertise. So exactly. You don't have to be a technical person to be part of this. Your knowledge of experiencing people that have this sort of ailment can also help with the design.
And since we are talking about an app that is related to dementia, even people that live with someone else with dementia, so you can bring your experience and say, yes, I have this difficulty in the past. I have this challenge here right now. So you need to think about this. So that's the main idea, not like to put everyone together around the same problem and the people come up, okay, I have something here that you need to take care. And if it's some medical practitioner, just come and say, yes, but you need to think about this another thing here. And a business analyst will be the same. A data architect will be the same. So everyone will be a good insight, and that can build this overall solution.
Perfect.
Yeah, definitely. So let me just tell you guys, apparently there are some questions in the chat for us. Okay, so I assume that João will help us in terms of the questions. Can you just load the first question as a banner? Yes, so we have here Andrew asking what's the implication in terms of the latency reduction in a medical sense for IoT?
Do you want me to answer that?
Well, we can try to answer that. That's one of us,
Say for a medical sense, if, for instance, something came up on my screen. Are you still seeing me? Yeah.
Yeah.
Okay. Right. So, in terms of latency reduction for medical, for medicine, let's put it that way. If you're carrying out an operation that you need to, something that's so time sensitive that you cannot afford for it to waste time. So a lag in you receiving that information could cost the person's life. I know that's an extreme, but in this regards, when I talked about latency, I was talking about the videos, the way there are some videos that while you are presenting, where you're talking, you're not getting the information, almost immediately. So we're looking for that platform that will make it almost instantaneously, almost zero latency, which at times we say it does not exist. But that's what we're trying to ensure that what we have should have that characteristic, if that makes sense. But latency reduction is so key when it comes to medicine, because it is a life and death scenario. If what you need is not being presented as at when it's due, and it could be disastrous. Yeah, that's my opinion about that.
Yeah,
we have also Lucy
here. Yes.
Sorry, go ahead, Vitor.
Go ahead, Matt.
We have Lucy as well. João, can you load Lucy's comment? So just to let you know, we are live streaming these sessions, but definitely it will be all recorded and made available post to these events. So you can recap and come back to the recordings and watch it again. Also, we have Marco making a question. Yes. So, Vitor, do you want to answer this question?
Or
maybe Edwin, sorry.
Yeah, Evelyn, I think it's Evelyn.
Sorry, Evelyn.
Well, I'll tell you what memory haven is. Memory haven is not just it's like a one-stop shop, if that makes sense. So there's no existing application that we know that has everything that we have. There could be bits and pieces here and there, but we combined a couple of stuff together to have it as a one-stop shop for people that need it. So I cannot categorically say there's one competitor that has everything that we have. But if I have to narrow it down to specifics, right? Say, for instance, the video, the and teleconsulting, so to speak, that is being used a lot in America at this, in Ireland where I live, I'm not aware of it being used, but I know in some other countries, there's what we call video consultation going on. Yeah, so that would be maybe some hospitals are using it at the moment in America, so to speak, not Ireland that I know of.
Yeah, we can say that memory having is basically, as you mentioned, is a one-stop shop, not just for the people with dementia, but for doctors, for the family, and everything that come together, integrate to help a single person or a group of person. Yeah.
Spot on.
Yeah, exactly. So that's what really amazing. So every time, the first time I just heard about you talk about this, I said, yes, there's a lot of things that memory haven can do. It's not just practical for us to help one single person, but can help the family, can help the integration between the patients and the family and the doctors and so on.
Yeah,
exactly. I have my question.
Also, I would like to let you know, everyone that is watching us, please, if you have any questions, drop your questions on the chats, and we are here to try to answer your questions. And before we go to the next session. So actually, I have a question for you, Evelyn. I believe it's a bit important on this. So as you know, the idea of this Ideathon is ultimately to try to help your projects, and essentially one important question is, do you have any hard deadlines in terms of when you need to essentially finalize your app and put everything in live, in production, to be used and so on?
We actually have a deadline date for end of October. It's tentative, but we know definitely by the end of the year, everything has to be up and running in the App Store.
Okay, great. Mm-hmm. Great. And so essentially, as you know, we invite, of course, everyone participating on this challenge, since the challenge only considers the design parts, okay? Afterwards, of course, depending on the solution that you design, you may have an opportunity as well to collaborate with Evelyn in order to find a way to implement your idea. And that's the most important thing. It's not only coming and dropping a document with your idea. No, it's actually your idea can become something real and become something that will be in production, being used by millions of people, and being helping millions of people all over the world.
Mm-hmm. Absolutely.
Yeah.
Can I do the one more question just before we just close out this?
Okay. Yes, of course.
So Evelyn, so what is the outcome you're expecting from after 24? What you're expecting to see? What are expectations about the 24?
What I'm expecting, that's interesting one. Yeah, I'm expecting to see several suggestions as to the best way to implement it, and probably the pros and the cons of using alternatives, so that we can now make informed decision based on the suggestions that are coming. Even maybe some things that could have just popped into your head without me even mentioning it. You could say, why don't you do this? Why don't you do that? That would be very welcome. But like I said, we're just hoping to see some good documentation in terms of if you use this application, or even some sketches, some designs is okay. This is the way it should be done. For instance, if you are doing the video call, some step-by-step procedure, that would be fantastic as well. But the whole idea is that we want to see an alternative and working towards the best option for each challenge posed across.
Yeah, and it makes totally sense. I'm expecting the same as you. I'm expecting people designing entire solutions that people just, okay, we are looking here, my group, we are looking for costs, for example. Here in my group, we are more technical, but what we're looking to see is by the final of the event, Evan look and say, yes, now I'm better than yesterday because I know more of this design of solution and how to implement this using this amount of documentation that was generated, this amount of conversation that I had today. So that I was expecting by the final of the event as well.
Absolutely.
Thank you so much, Evelyn.
And one important to add on this, Evelyn, is we are looking for to we are going to do some guidelines, to provide some guidelines and some rules to the participants in order to ensure that the deliverables that they will give to us in the context of the challenge are consistent and standards, and it's aligned with what we expect, as an outcome from this challenge. So definitely, that's why it's important to understand definitely your expectations on this, so we can align and ensure that we get the outcomes that you expect. This.
That makes so much sense. Yeah.
Yes.
Mm-hmm.
So I think we don't have any more questions. I think so. So we have some comments from different people in the chats. I appreciate. Thank you for interacting with us. There are a lot of people apparently excited with this project and with this challenge. So it's a good sign. We expect a good number of people participating on this challenge. So again, it's totally free. It's totally welcoming everyone, even non-tech people and non-developers. You don't need to know how to code in order to participate. It's all about designing the solution. So it's all about having ideas to solve the challenge. And we will be during today opening the sign up to enable you to sign up individually or sign up with your team. And I think João wants to come in and say something.
I'm back. So thank you very much, Evelyn, Hugo, Victor. This sounds such an amazing opportunity, an amazing project. I think if you miss it, you're going to regret it. So I guess with this, we can wrap up the first session of the day, right? And it sounds that the Ideathon day will be such an amazing day. So now we'll have a short break and we'll be back at 11 with Ishan for the application design and integration session. So until then.
Thank you.
Thank you, John. Thank you, Evelyn. Thank you, Hugo. Bye-bye, guys.
Bye.
Hello, everyone, and welcome back to this Cloud Lunch and Learn Kickoff Ideathon Day. For this next session, we have with us Ashin Jain. Did I say this correctly, Ishan?
No, it's Ishan.
All right, sorry, Ishan. So,
It's okay.
how are you doing today?
I'm good. It's nice weather.
Okay, excited to go?
Yeah.
So, Ishan is here as a cloud solution architect for Data ANNI and Microsoft, and he will present a session about application design and integration. So,
Yep.
over to you, Ishan.
Yep.
So before we start Ishan's session, I would like to ask you to register for this event by scanning the QR codes or accessing the link on the screen so we can get metrics of the event, and it will be a huge help for us. So if you don't mind, please take a minute and fill in this quick form. So over to you, Ishan.
Yeah, maybe I should let it go for a minute or so. Yeah. Yeah. So my name is Ishan, and I'm going to talk about like modern app design and integrations in cloud, and specifically Azure, as I am Data and AI CSA at Microsoft. A bit about me. As I said, my name is Ishan, and I'm a cloud solution architect at Microsoft, which means that I'm more of a technical advisor and a business analyst. So I analyze what the needs customer has, and then I help together with the customers create a architecture which they are happy with, and then help them with implementation of the architecture. Uh, a quick agenda. So we are going to talk about some cloud design patterns, not too deeply, very high level, and some how we can utilize Azure for app development and integrations. And yeah, I will go over a couple of Azure's integration services. As you might know, Azure has over 600 services. So I will just go with a couple of them. There is some, so to say, problems in cloud applications. Like when you think traditional in a data center, these things were not as prominent as they're in cloud. Partially because you don't actually have the access to the hardware. So resiliency, scalability, security, availability, management, monitoring, messaging, distributed data management, design implementation. These are a bit of tricky things you need to, how do you say it, remember when you're designing a new architecture for a modern cloud application. Resiliency is when, like, if one node goes down, you should be able to, within a couple of seconds, have another node working, so that you have as little as downtime. Scalability will be like if you have, let's say, off peak, only like 100 customers coming to your site, but at peak you have 100,000. So you need to be able to scale between these vastly different amount of visitors. Security, obviously, we need to be able to secure our data with other laws and regulations coming as GDPR and so on, getting more and more focus. Availability, it should be available nowhere where you are in the world today, so that you cannot just, oh, our most of the customers are in Europe, so we don't need to cater for the rest of the world. That's not the case today. Management and monitoring, you need to be able to manage your application in cloud. Earlier, you could, like if you had a traditional data center, you could just remote desktop into the application and do whatever you wanted. But now you have more management through, like in Azure case, like Azure Portal and so on. Monitoring will be so that you know something happens and you have an alert, or you can have telemetry, how the application is doing at any time. Messaging will be more for like stateless, and more async communications. For instance, like you have an e-commerce site with a basket cart. When you add data to it, or when you add items to it, you don't want to like the whole page to hang there for until the operation is done. You just fire a message to the message queue or service bus and then forget about it. And then when that's done, the cart will notify the user again that yeah, it's added. Then you can show a pop-up. Distributed data, it's more like, as I said, availability, like you will need to be able to cater for a global audience. And so comes distributed data. For that, we have something like Cosmos, which is a distributed database by design, so that it doesn't matter where the customer is, your end user is, they will have as low latency as possible. In web, we actually used to do measure a thing called time to first byte, and that's what we try to minimize here. Design and implementation is more like how you go through all of the above and then design a good modern cloud application. And then implementation, again, you don't have access to a like SSH or RDP, in this case, remote desktop. So you need to be able to use things like CI/CD or DevOps in order to like deploy application. So these are a bit of challenges we have with cloud applications. So, and Microsoft have designed a lot of cloud design patterns. I believe these are like 15 patterns divided in 3 categories: resiliency, availability, security, and scalability. As I said, I will not go through all of them. If I do that, we will be sitting here for days. So I will try to, what do you say, demonstrate some of them through some architecture designs. If we look at our traditional web application, so you have a web server and it talks to a database. So whenever a user asks for a web page, it goes to the site. Thus, the web server will ask the database for the data and then deliver it. That's all fine. But when we have a bit more traffic, we might want to do maybe a CDN so that it caches some of the static data so that we have better performance. And if we have even more visitors coming or customers coming to our site, we will need maybe to scale it with maybe a lot of front ends, and then maybe even the database needs to be scaled with a load balancer in between. But if we go to web, we don't actually need to think about like how our load balancers are working, how they're doing. It's already built in. So if you're using PaaS services in Azure, you don't need to think about that. So let's replace, if we go back, no. If we replace the like multiple front ends of multiple web servers and multiple SQL servers with something called app service or Azure SQL in Azure. So you just need to think about one service instead of, in this case, was two web servers and one load balancer for SQL and 2 SQL servers. Now it's only 2, down from 5. And it is infinite scale. Within some reason, like it has to do with more like which tier you choose, but you can scale infinitely. And that is just by creating rules, nothing else. You don't need to provision new servers. You don't need to think about, okay, it's going to take half an hour to provision new server. How do we do that, and so on. It's already done, and usually these new servers are up and running, or services are up and running within minutes. And if you go back to like our simplify it again, we might want to add like some sort of federation or identity. So in Azure, we have Azure AD. So let's put it there. And then let's say I want to monitor what's going on with my application. Here, I have application insights, which takes data from app service, pushes into a log workspace, and same thing with SQL Server. It will take telemetry and push it to Azure Monitor, and Azure Monitor will push it to log workspace. And now, because we have a combined data set of both web and database, we can actually query the log and see how it actually performing as a more unified plane, instead of like traditionally you have your log files from web server, your log files from database server, and you try to combine them. Here it's done for you. And from that, you can generate dashboards, diagnostic reports, or even alerts. Let's say you have a 100 units web server, and you are hitting something like 90% of that. You will want to know when that happens. Even though if you have an auto scale in place, you will want to know, okay, we are using 90% of our capacity. Or when your disk in your database server is getting full, or your storage area that you have provisioned. And there is also a cost alerts, so that you can say, let's say that you have a budget of $100 a month, and you are hitting 90% of that, and you will maybe want to scale down some of the services, some of like good to have services. So you can do that with automatically. And then if you talk about containers or serverless or any other type of topology, it's usually the same. It's just that you replace your web server with a Kubernetes cluster, in this case AKS cluster. And maybe to give it a bit more security, we would like to place an application gateway in front of it for application firewall or some sort of load balancing rules and so on. AKS does come with a built-in load balancer, so you don't need to think about it. Let's expand the metaphor and then look at how the new modern serverless single-page application works. So here, I don't have any web service. I have an API management, which talks to my functions. And then function, in this case, will talk to Cosmos DB. But because this is a single-page application, I have a CDN, which will actually just get the data from my blob storage. So I'm not reliant on compute at all the time. So user comes in, user asks for the site. The CDN will deliver let's say, Angular or React or Vue site. And then that site will help the user to authenticate with Azure AD, and then get the data as an API from function with help API management. And API management is here also acting as a proxy, firewall, gatekeeper, and so on. So you have a lot of things built into a single service. And function is, you just fire and forget, basically. So it's a single method which works. So it will only do one thing. You don't have access to a class, so you only have access to a method in the class. So everything has to be stateless. And again, Cosmos, easy to use, globally distributed, so you can have it anywhere in the world. And if we expand it again to maybe use something like real-time chat. So we have something called Signal R, which will, in this case, contact another function, which will talk to a database. Signal R uses either WebSocket, long pull, push, or other type of technology, depending on it has a tier design. So depending on what type of browser you're using and so on. So if you're using a modern browser, you will have access to WebSockets. So it will use that. If not, it will fall back to something like a long push or pull, and so on. So this is a real-time protocol built and I have used it for last 10 years, so it's very resilient, very powerful, and you can actually build real-time chat and so on without even knowing how to code WebSocket or think about how to manage things when WebSocket fails or it's not present. And if you want, we can actually insert a Redis cache in between like function and database. So if we know that we have these particular type of queries coming time and time again, so we can actually cache that data and put it in Redis. And everything in Azure is actually, as we call it, a set of like Lego pieces. So you can change anything with like any layer of your architecture with similar service, depending on what your need is. Like here, I have an input from either from a user or a device. It can be IoT device, it can be a mobile device, doesn't matter. And for identity, we can choose between B2B or B2C Azure Active Directory. B2C helps you to integrate with or authenticate user with social accounts like Facebook, Google, Microsoft account, LinkedIn, and so on. While Azure AD only has something like SAML or OpenID. And then if you go to the security load balancer network layer, you have front door, CDN, application gateway, traffic manager, or if you're building an internal application, maybe you will need to have a VPN instead. What traffic manager does, it distributes the data so that if I'm coming from, let's say, Dublin and somebody else is coming from US, so I will go to the Dublin data center while somebody who is coming from US will go to the US data center. Application gateway, as I said before, is more a application firewall. Then we have CDN, which helps you to cache data on a much closer to user. And front door is a combination of all of these for more enterprise grade solutions. And then we have something like ingestion control, which can be like API management or event grid. Event grid can handle millions of simultaneous telemetry points at once, so that you don't have this. I remember back like 10 years ago, we used to measure performance of a web server with how many requests per second it could handle. A good measurement at the time was 20K. But with everything being IoT enabled and so on, that doesn't hold anymore. That standard is too old. So what Event Grid does, it actually can handle millions or upon 100 millions even of requests per second. And what it does is it actually puts the data into like something like a blob storage or something, and then gives you, and then you can use something else, another thing from compute level or anything else to actually process the data as soon as your service can process. So you're not, so ingestion is not dependent on compute anymore. And for compute, we have things like logic apps, which are more drag and drop connectors so that you can connect to some, even like things like SAP, Dynamics 365, Office 365, and so on, and create a workflow visually. For instance, one of the example we create for the logic apps is you have a keyword in like a hashtag in Twitter, and then we monitor Twitter, and then the logic app will look at the Twitter feed like every 5 minutes and gather all the posts with that hashtag, and then we'll show them in a nice dashboard. Functions, it's just a piece of code without any server in bottom, which you need to think about. AKS is more Kubernetes cluster, containers and such, so that you can actually make your own, like, so that Kubernetes has its own controls and stuff. A lot of these things can be built into Kubernetes, something like gateway and load balancer, but usually we recommend to use something other on top of it anyway. Then you have standard web apps or app service web apps, and then last one is something like service bus, so that you can actually put something on a service bus and then you can subscribe to that queue and then process it when the compute can. Then if you want to look at more traditional systems, then you can like still use VMs in Azure, but today with modern applications, we don't recommend using VMs because you get a lot more bang for the buck with our platform as a service services. And lastly, you have your cache or storage layer. So you can dump the data in a blob storage, which is just a bucket. Basically, you just dump it. You have a distributed multi-reason Cosmos DB. Azure SQL is very cheap, very resilient SQL Server, and it has infinite scale, different type of offerings, and then we also have things like MySQL, Postgres. So you are not in Azure today. You are not limited to like Microsoft first-party products. So things like Redis, Postgres, or MySQL are treated as first-party products in Azure. Now let's look at the how. Earlier, I have been talking about how you do like web applications, basically. But what about you don't need an application? You just need to your application is not a web application. It's more like an ingestion of data and how you process the data. And I say I made a mistake there, but okay. So when we talk about modern data warehouse, it's not that you need to get the big beefy data warehouse solution from Microsoft. It is more of a what do you say, terminology, how you process the data. So you can have things like unstructured data in JSON or images even or videos, or you have structured data in form of SQL database or another type of database. And then we use something called Data Factory to ingest the data. And then we store the data in something called Azure Data Lake. Data Lake is a big sink of hole where you just put the data and forget about it, basically, or you can forget about it. And now that all the data we need, it can be on-prem or it can be in cloud or third-party cloud or anywhere. But because now it's in a data lake in Azure, so any Azure service can access it. Like Databricks or Synapse, which is our new data warehouse solution. You can use Jupyter Notebooks instead of Databricks. You can use Spark if you want. And then from there, you can either use analysis services to make a tabular model or directly publish that to Power BI. And you don't need to have Synapse as a store for your tabular data. You can have standard Azure SQL. And if we go more, so how do you do advanced analytics? So you might want to have like a portal, not only just a Power BI report, but also a portal where user can see real-time data. Or how the things are doing. So you can publish the data from any service like Databricks, Synapse, Jupyter, Spark, even Hadoop to a Cosmos. And then Cosmos can view it on a web page or a dashboard, which you have made custom dashboard. And then lastly, how do we do with real time? How will we deal with real time? Again, as I talked before, Event Grid can get data from anywhere and then publish and then store the data in Azure Data Lake. Azure Data Lake fundamentally is just a blob storage. So you can store anything there. And you can actually access a data lake as a blob storage if you want. There are drivers for that in build. And then again, you can, a real-time scenario will be, let's say that you have IoT devices, but you want to see you don't want to know what the data telemetry you're getting, but just the status of the devices. That might be something you will actually publish to a web portal before crunching all the data. So that type of data I will probably store in a Cosmos DB and then display in a dashboard. And with that, we can actually create things like digital twins, so that you actually have a 2D or 3D representation of your whole device you are getting the data from. That's all I had. So do we have any questions?
Hey, Shen. Yes, you actually have a couple of questions, so I'm gonna
Yeah,
pop
good.
them to the screen. So the first one is this one.
What are the challenges faced by IoT applications? Are faced by IoT applications? And one of the biggest thing I see that people forget about is security, because a lot of time I see that a lot of IoT devices are actually open to the internet. They're connected to the internet without any sort of firewall within the device. Because if you have a compromised device on your, like in your IoT scenario, then you can actually, or a IoT sensor is compromised, you can actually compromise the whole system. Then there is monitoring and all that. Like, yeah.
So how would you secure an IoT system then?
If you go back, sorry.
So, Ishan?
Yeah.
So let me ask you then one thing, still on the IoT bit. So what would you use to secure an IoT device then, if you're going with an Azure solution, for example?
We have something called I believe I don't have that slide anymore. Yeah, we have something called in Azure IoT Hub, and that can speak to something called IoT Edge. And IoT Edge can be something like Raspberry Pi with Microsoft's IoT image, and that has built-in security, so that instead of each and every sensor talking to the IoT Hub or Event Grid, they talk to the IoT Edge, and IoT Edge will in turn talk to. So that it's only a single point that is talking to the internet instead of each and every device.
Okay. What about areas with low connectivity, for example, where
Yeah, that's
broadband is not
where
very
things like
available?
IoT Edge actually shines, because then you only need one device that needs internet connection instead of multiple sensors.
Okay.
And you can buffer, like, let's say you have a spot connection, like only sometime but not always. So IoT Edge can actually buffer the connection or buffer the data before it sends.
Okay, that makes total sense to me. We still have a couple more questions.
Yeah.
So the next one is this one.
Logic app is Logic apps the same as Power BI Automate? No. Logic apps is more what we call enterprise grade, while Power Automate is more consumer grade. So that Logic apps has more higher priority, and you know it's going to run, while Power Automate might have a delay of up to like 2 or 3 minutes whenever it gets to the next slot, while Logic apps will run when you say it will run. They are built on a similar they use a similar engine or same engine in the bottom, but it has the prioritizing is a difference. And like I think they do share the same connectors between Logic Apps and Power Automate also.
Okay, like I would think that Power Automate would be more organizational, enterprise focused. Like something
No,
you would use.
it's more for like individuals. You do more like, this is
So is
my
it
Outlook. I get an email. I want a notification on my phone.
Okay.
While Logic Apps is more on enterprise level, like more on like here's our Dynamics 365. We want to take all our data from Dynamics 365, store into a data warehouse.
Okay, so you're talking like citizen developers
Yeah.
in an organization would go for Power Automate
Yeah.
and Logic Apps for the, you know, cloud
Developers.
architectures, developers that would be outside of it and had to like probably
Yeah.
integrate with a lot of different systems.
Exactly. So Logic Apps is more like we used to talk about a couple of years ago, BizTalk server.
Yeah.
So this is more replacement for BizTalk, while Power Automate is enabling that technology for citizens.
Yeah, I remember BizTalk services on
Yes.
Azure a long time ago. It was quite an expensive thing to get up and
It's
running.
still there. It's still there.
I think we have a couple more questions.
Yep.
Let me just find them. Okay. Okay, here it is. Another one on IoT and Edge.
In the recent years, to minimize latency security, etc., edge computing was introduced and seemed to be a better choice for IoT devices. Can you comment on this, please? Well, that's what I talked about. Like you can use a edge device like what we call IoT Edge, or if you really need something, you can use something called Stack Edge. It is more to like so that not each and every like let's say you have a smart building which has millions of sensors. You don't want that millions of sensors talking to the internet individually. You want to have some sort of organization, organized data instead of anarchy. So each and everything is firing. So that you will use something like in that case, if you have millions of sensors, you might actually have a stack edge, which act as a IoT edge device in this case. But you can, as I said before, you can actually use a Raspberry Pi. You don't need to go and buy a specialized device, even though we do recommend that, because then you have better support from the manufacturer and so on.
Okay, so let's move to the next one.
Could you use a real-world example for when data is being produced to the output to customers, users via Power BI application? Sure. Real-world example will be, let's say we are doing this event now, Ideathon, and we want to gather all telemetry, like how many people are watching at certain hours. So we can actually ingest that data, each and every talk, every minute, how many people viewers were there, and then we can actually plot a graph in Power BI. That's a very simple example. But if we go further, another will be like, I have, again, smart building, and I want to see each and every room what temperature it is on at each and at a second level, level of like a millisecond or something. So I can actually plot that and see where it is actually fluctuating in a Power BI report. After crunching the data, I can plot it in a Power BI report and have several graphs like this room, or I can have peaks, lows, and so on, different type of data plotted.
Still on no, so this is one for me, right? For me.
Yeah.
Still on the IoT bit. So what
Yeah.
sort of tools would you use to process all that amount of information that I believe it will be massive, right? And get results out of it in real time or as close as possible to it.
Mm-hmm. As I showed you an example, you can use any compute node as you want in Azure, but I personally will prefer something like Databricks, because then I have access to Python notebooks or Spark and even Java in there. So I can mix match my languages and do a lot of crunching. And what Databricks does, it can scale up to like 60, I believe 90 nodes or something. So you can have parallel processing.
Okay. Like I from I personal experience, I used Stream Analytics.
Yep, that you can
For
also use that. I'm not that familiar with that, so that's why I talk about Databricks, because I'm more familiar with that.
yeah, like it was for a short project, but it was actually very easy
Mm-hmm.
to use. All paths, no need
Yeah.
for virtual machines or anything. SQL syntax with JavaScript for specific
Mhm.
user-defined functions. It's really easy to set up and get it up and running. So,
And if if you use Jupyter Notebook on your laptop or desktop or computer, local computer, we actually have a free offering of Jupyter Notebook in Azure.
okay, that's cool. All right, so we have a couple more. So
Yep, we still have time.
yeah, no, I know. So Power Automate again.
So with Power Automate, the SLA is different, but so are the costs. Yes, SLA actually, the higher the SLA you're going to get, the more the cost will be, and that is true for almost all the Azure services. And also Power Automate, it's not Power BI Automate, it's Power Automate. And Power Automate is part of what we call modern workplace suite, not Azure suite. So it is more in line with the Office. So you have to think about like individuals working with that instead of like IT department. And that's why you have different SLAs, because as an individual, it doesn't matter if you get an alert 2 minutes later, then immediately. But in a organization on an IT level, 2 minutes, like in a stock exchange, can mean loss of millions.
One thing that just came to my mind on Power Automate, we do have, I think, a functionality that we don't get in Logic Apps, if I'm correct, which is like the bots or the virtual agents.
Uh, for that, you actually have that has been broken out as a bot services in cognitive services. So that thing is utilizing that. So you have it. It's not part of Logic Apps, but it is in Azure.
Okay. Yeah, that I remember. I think it's tightly integrated on Power Automate.
Yeah.
Kind of like
Because in Power Automate, again, it's more for citizen developers. So we want to make it as easy as possible. So instead of like using Excel or VBA to do that, you can use Power Automate.
It's like get away from that.
Yeah.
Okay, there's one more.
Are the Azure Communication Service available in time for these services? Or do you have be using? I'm not familiar with Azure Communication Services, so I cannot answer that.
Well, I think that's it in terms of questions. Unless, like, should we give it one more minute?
Yeah,
See if something
sure.
else pops up. Until then, I'll just ask for everyone again to please register the event. Use the QR code that's on the on the screen. Again, that will help us a lot in get metrics and understand what will
And
be.
further funding for Microsoft.
Yes.
Because the more people who sign up on this QR code will actually enable us to provide more funding. Because then we can show that yes, there is a market value or business value for Microsoft sponsoring these events.
Okay, there's one more thing.
Yeah.
One more question here.
Orbital, no, I don't.
Don't have the connections yet to get access to it.
It's more like none of my customer has asked me for it yet. Unless I have a business case, we don't usually get access to the new and shiny. It's not us who get the access, the customers.
It's a shame. But you want to get your hands on it and
Well, I'm
give
more
it
in
a
the
run.
data space now, so I have been experimenting with Synapse.
Okay. Okay. I think if there's nothing else, we can wrap this up, I guess.
Yep.
So, thank you, Ishan,
Thank you.
for this amazing
Thanks
session.
for having me.
Hope everyone enjoyed it. we'll have a short break now, and we'll be back at 12 with Martin for the business continuity, performance, and availability session. So until then.
Hey,
Hello, hello.
how are you doing?
Not too bad. Not too bad. What
Awesome.
about you?
Good, thank you. I've been loving watching the sessions this morning. I love the idea of the Ideathon. It's such a I think it's such an awesome way to provide an opportunity for everyone to get involved to solve a real life and a really important problem. And I'm excited.
Yeah, it's a different approach, I think, to
Yeah,
what we're used to.
yeah.
And the project sounds so exciting.
Yeah, the project does sound so exciting, and it's something that's going to be so valuable to so many people. So, big shout out to Evelyn for working on this. That's just awesome. So everyone who is currently watching, we would really appreciate it if you could go to the link that you see on screen or scan the QR code that you see there. And you'll get access to Microsoft resources for the sessions that we're doing today. So resources that are relevant to the sessions that you're seeing on your screen. Access to learning materials, that's always good. But also it provides us with some statistics for the Cloud Lunch and Learn group and how well we're doing, which we feed back to Microsoft, which is really important. So please do scan the QR code, let us know that you're here, and that would be amazing. And I think even if you do that when it's published as recorded, that would be grand. So, yes. And then coming up in a few minutes, we're going to have a session all about business continuity, performance, and availability, which is always an important topic.
Looking forward to it.
Yeah.
Still
Be
have a
good.
couple of minutes, right,
Yep.
Lisa?
Yep.
So
We do. We've got a
you
couple of
have
minutes.
done a couple of moderation for some CLL sessions, haven't
Yes,
you?
yes, I
You're
have.
kind of like our master moderator, an expert, I would say.
Thanks so much. I wouldn't say that I'm a master yet. I would say that I was maybe just like one of the first moderators. So it's all practice. But I really enjoy it. I get to learn about various topics and also engage with the community and those who join us for the session. So yeah, I really like it and I really enjoy doing it. I like to talk, so it's good.
Yeah, you have run podcast and everything.
Yes, I do have a podcast. So I have a podcast called Lisa at the Edge. It's all about hybrid cloud, specifically around Azure Stack, Microsoft Azure Stack, their hybrid cloud portfolio, as well as careers in tech. So I like to chat to people who have interesting stories on how they got in to tech. And what I've been learning is there are varied stories on how people got into tech. And I love that. I think it's really important to showcase that so that we can attract all sorts of people to the technical community. I think that's important now than ever, especially like we're discussing today when we're developing technical solutions for people, vulnerable people, like people with dementia, which is the problem in the Ideathon here. But yeah, technology is now just linked into our lives in such a personal way that I think it's really important that the people behind the technology are a good, varied and diverse group of people. So I like to hear about how people got into tech and I like to share those stories. So yeah, you can find me, Lisa at the Edge, on Spotify, iTunes, Google Podcasts. There's 20 episodes up there right now, and I'll should be starting to schedule in more episodes around October. I took a little bit of a break.
I think it's good to see this sort of like this type of project, see technology making a difference.
Yeah,
Not
absolutely.
but for everything, not just for this type of approach. Even climate change, for example, how you can build your applications and your infrastructure in a more greener way.
Yeah.
Like, so it just makes it more and more exciting to see what we can do with it and how it will improve like everything.
Yeah, it's becoming a lot more real and tangible and relatable. And it's so important in, like you say, climate change and all of the big issues that affect us. I mean, look at where we are right now in the pandemic and how technology has enabled us to stay connected, how it's enabled businesses to continue to run when people are working from home, and how it will inevitably be playing a part in the try to speed up the process of finding a vaccine. So yeah, it's an exciting place to be right now. And I love this. I love the idea of the Ideathon, where we get to be closer to those real life problems that we can try and solve with tech. So, what's the time? Let's go. Let's play.
It is time, yeah.
Yeah.
So I'll hand over to you now. Sorry, I will shut
That's
up.
okay. Cool, no worries. Thank you.
Go on.
So I'm just going to, okay. So we've got the next session is all about business continuity, performance and availability, which is a super important topic for any application that you're going to design. Martin, unfortunately, could not be with us today, but he has very kindly recorded his session so that we can share it with you. Martin is a senior Azure consultant with Enzo. He's also a member of the DevOps Institute. And Martin also runs a podcast called DevOps Squared, where you can listen to him chat to lots of different people about DevOps topics. And he was actually on Lisa at the Edge, where we talk about DevOps as well. We actually didn't mention any technology because it's all about people at the end of the day. So with that said, what I'm going to do is I am going to play Martin's talk for you. And you can check him out on Twitter at Mr. Coops if you have any questions. But I'll disappear off your screen now and I will play the video for you guys.
Available. So just a little bit about me. So my name is Matt. Also within Sono. They're a US-based company. What you've invested so much time and so much money in is available and perform.
Lisa, I think something's going on with the audio. Do you mind resharing again with the share audio tick box on?
Yeah, apologies, guys. I thought I'd done that. Hold on. Yes. Sorry, guys. I clicked it last time, but right. Shall we restart the video? We were only a minute and 30 seconds in, so if I just hurry up, we can Okay. Let's go. Sorry, guys.
Everyone. So first of all, thanks very much for the invite from the Cloud Lunch and Learn team. It's very good to be here. And in this session, we're going to be looking at keeping your cloud performing and available. So just a little bit about me. So my name is Martin Copeland. I'm Principal Technical Consultant within Sono. They're a US-based company. I'm a managed service provider, and I primarily work with customers around cloud native technology, so platform as a service, generally speaking, and also DevOps as well, as we start to move more into the DevOps stack. But today, I'm going to be talking to you about how you keep your investments in Microsoft Azure, primarily performing and available. One of the things that we talk to clients about all the time is, when you've moved to the cloud, how do you make sure that what you've invested so much time and so much money in is available and performs to your expectations? It's a really important subject that quite a lot of people often don't pay a great deal of attention to. So once again, thanks for the opportunity to let me share some of these things with you. So we're gonna cover three primary topics in this talk, really. So the first one's around architecting for performance. So we need to make sure that what we build in the cloud is performant. And what do we mean by performant? We need to make sure that whatever we build and whatever services we use are able to serve the number of clients connecting to that application or to that service at any one time. And there's a number of different things that we need to take into consideration, including application design and how we monitor some of those things as well. So we'll go into some of those. We'll also go into the same kind of topics as well when we talk about architecting for availability. It's really important that we architect our applications to be as available as possible. Sounds really simple, but quite a lot of customers don't put a lot of effort into this, and it's really important to make sure that this is taken care of. Last thing you want is for your business critical application to be unavailable, especially during peak times for your organization. So it is really important to make sure that this gets the care and attention it desires, to make sure that you are, quite frankly, not on the front page of the news talking about your system or platform being unavailable. Disasters do happen, so it's wise to plan for them. And this is what the final section in here is all about, really. So we're going to talk about how to make sure that we plan for events that may happen that cause disruption to your services, and what you can do to ensure that your services stay as available as possible and make use of the distributed platform that you've decided to architect your application on, that is the cloud. Okay, so first of all, architecting for performance. So there's a number of things that we need to consider, like you're saying. And there's a number of things in here that we need to really look at and pay attention when it comes to what we put up in the cloud and how we work with the cloud. So the first thing is around partitioning your workloads. So you should always design parts of your organization, parts of your application, your process, to be discrete and decomposable. What do we mean by this? What it really means is that we need to minimize as much as possible each part of the application. So this allows components to be distributed in numerous different ways that maximizes each compute unit. It also makes it very easy to scale an application by adding instances of specific resources. For really complex applications, this is where you might consider adopting a microservice-based architecture. And that architecture may be deployed into containers, it may be deployed into APIs that are delivered through app services in Azure, or maybe something else. It may be APIs that are covered by function apps. Whatever level you go down and whichever design pattern you go down, it's important to take this into account, because this micro-segmentation of services, if you like, this microservice-based architecture can give us the ability to scale a lot quicker and also react more fundamentally, not just to performance issues, but availability issues as well. We should also design for scaling and plan for growth. So normally speaking, we would generally know through design workshops that we do with clients what the load is going to be like on those applications. when it's going to be quiet, when it's going to be busy, and we will know what things that we need to take into account to make sure that that application stays as performant as possible. We can use scaling in the cloud, things like auto scaling as well, to make sure that those applications increase and decrease the number of instances. That may be something to do with roles, queues, or any other type of service phraseology that you like in there. However, the application must be designed with this in mind. For example, if the application uses the services and they must be stateless to allow requests to be routed to any single instance, having stateless services also means that adding or removing an instance does not adversely impact current users. So not if this is an architecture pattern that you choose to go with, you need to make sure that your application can actually support the pattern that you are going for. Sometimes we know when we're going to receive peaks in demand. So think of various different industries. E-commerce is the biggest example that I can give here. Any e-commerce platform, whenever that organization has a sale or an event on there, we'll expect higher demanding traffic. I've worked with clients before where we've put those metrics and those periods of time into the platform to make sure that we understand that instead of running on a minimum of 2 instances, when this event is happening, we need to run on a minimum of 4, but still auto scale if needed. When we plan for growth, for each resource that you deploy, you must know the upper scaling limits. And then you can employ certain technologies such as decomposition or maybe sharding to go beyond those limits. So you need to make sure that the application is designed so that it's easily scaled by adding 1 or more skill units. You can determine the number of skill units for the system in terms of well-defined sets of resources. That will then make the scaling out operations easier and less prone to a negative impact caused by a lack of resources in other parts of the overall system. And so a good example of this, for instance, you can add X number front-end VMs that might require Y number of additional service bus queues and Z number of storage accounts to handle the additional workload. So a scale unit could consist of X VM instances, Y number of queues, and Z storage accounts. So when you think about scaling and scale units, don't think of scale units as individual resources like VMs, queues, or storage accounts in that example. Think of the storage unit think of a scale unit as all of them, because that will give you the ability to scale everything to the expected level that you need without having to have multiple different plans and processes in place. Treat the application as a whole wherever possible. The next one actually should say avoid affinity. It says avail, apologies for that. So wherever possible, ensure that your application does not require any level of affinity. Make sure that requests is more for web applications, but it would apply to applications hosted on application servers as well. Make sure that any request can be routed to any instance and that the number of instances is irrelevant. So that avoids any overhead with storing, retrieving, and maintaining state information for each user. So make sure that your applications are effectively can be handled by any system within the platform. So we talked about auto scaling a little bit. So make use of the built-in auto scaling features wherever possible, rather than something custom or something third party. You know, there's an old adage really, which is if it's not broke, don't fix it. And this can be said with platform-based features as well. So if there's a platform feature that will do what you want it to, or do a vast majority of what you want it to, say 80%, then there really is no need to go off and build your own custom thing. Make the process work for you. There is no point in going off and building something else on top of the platform that already exists. It's just going to add overhead, it's going to add problems, and it's going to add a layer of complexity that in a scaling scenario you don't need. If your application isn't configured to scale out automatically as load increases, then your application services may fail if they become saturated with user requests. So it's really important to make sure that the application that sits on top can actually scale, because be warned, not all applications can scale out of the box, especially with commercial off-the-shelf software. You may need to make some changes to the architecture or the application to make that happen. Okay, so distribute the workload for background tasks. So this is quite a common one that software developers have done for quite some time, actually. So if there's a number of background tasks, or some of those background tasks require considerable amount of time or are fairly resource hungry, spread that work across multiple units. So threading is the common term used in software engineering. So this is around threading. One possible solution for this, I have a link at the end to the architecture best practices, is to employ a competing consumers pattern. This will enable you, if this is what you need to do in that scenario, to have your background tasks work across multiple compute layers of your background. So that's one thing that would be good for you to look at if you have that scenario in your application. So once again, competing consumers pattern is what you're looking for, and the link is at the end. Consider moving to a shared nothing architecture. So some of you may remember shared nothing architecture from the Hyper-V and System Center Virtual Machine Manager days. It was a terminology used to describe the level of the hypervisor where VMs could fail over. So this architecture uses independent and self-sufficient nodes that really have no single point of contention, such as any shared services or any shared storage. So in theory, such a system can then scale, frankly, indefinitely. Although fully shared nothing approach is generally not practical by all means, it does provide opportunities to be able to design for better scalability. So good examples of moving towards a shared nothing architecture would include partitioning data. We talked a little bit about partitioning at the front, but data is a very big part of that. And avoiding using session state and client affinity. So whenever we use server-side session state, so a lot of web applications would store session state in a database. That's what we mean by avoiding the use of server-side state data and then client affinity that we've been talking about as well. Last but not least on here is a couple of things that are quite close to my heart. I've seen clients have issues with this for some time, actually. And one thing that you really need to be thinking about is Azure itself has limits. The services that you deploy on top of have physical limits when it comes to scalability and also performance targets. No more so than storage, where different storage tiers are available. So Azure Storage is designed to function as with a lot of other, in fact, as with all Azure resources, within predefined scalability and performance targets. So it's really important to make sure that you design your application to use storage within those targets. If you start to exceed those targets, your application will experience throttling on the storage layer. You can avoid the throttling by provisioning additional accounts if needed. If you run up against the storage account limit, you need to then look at additional provisioned storage accounts within different subscriptions maybe, or looking at increasing some of the quota limits. So it's really important to think about the platform that you're sitting on as well. We would have remembered things like this when it comes to on-premises architecture and private cloud. It still needs to be thought about when it comes to the public cloud as well. And then lastly on here, not just for VMs, but also any underlying resource really, make sure you select the right SKU for your application. This links back a little bit to the point above. Again, everything is functioned to work within a predefined set of targets. Make sure your application works within those targets and pick the right SKU for the level of performance that you need within your application. That is something that is really, really important. Okay, so application design is also another big part of this as well. So it's okay knowing what things to look out for when it comes to performance, but we also quite rightly need to look at some of the design decisions that we can make. So there's a few interesting ones on here, and some of these will be really common as we go through, even if you've never heard of the actual names themselves. So the first one is around dynamic service discovery. Okay, so clients can use either client-side or server-side discovery to determine the location of a service instance to be able to send a request. So service discovery is a process of figuring out how to connect a service, and if done correctly, can then lead to software that scales out as usage increases. Decomposing your application further into microservices is the practice that can lead to native scalability, given that service's ability to scale up and down individually. We talked about that a little bit on the first slide. That level of decoupling is actually an architectural best practice. However, when there are many different microservices in play, managing, executing, and operationalizing those services can become a bottleneck and can lead to the incorporation of an orchestration platform. So Kubernetes is the obvious one that springs to mind, AKS, or maybe even Service Fabric. That's another option as well. Both of those platforms provide built-in services for executing, scaling, and operating that microservice architecture. And one of those key services is also discovery and finding where a particular service is running. So the client of that service in this architecture does not need to or should not need to know or frankly care where the service executes or how many instances of the service are executing, okay? It's the job of the orchestration platform, i.e. Kubernetes or Service Fabric or something else, to perform the connection of that client to the service through the discovery service, such as DNS. All major orchestration platforms will provide this level of service and this level of detail. So dynamic service discovery can make the application more scalable because each service can then be scaled independently without the client's knowledge of the individual instances. So that is a really key thing if you think about very large scale applications and the ability to scale individual instances. Okay, so connection pooling is again, another one that's important when it comes to databases. So establishing connections to databases is quite an expensive operation in terms of the actual processing power required to do that, and the amount of compute, not in terms of cost. So it involves establishing some authentication to a remote database server. Pooling and reusing any cached connections is quite a common best practice for improving application performance and scalability. So in many cases, the default pool size may only consist of a handful of connections that performs quite quickly in basic test scenarios, but they will soon become a bottleneck under scale when the pool is exhausted. So establishing a pool size that maps directly to the number of concurrent transactions on each application instance is the best practice that we're talking about here. So you can use monitoring tools to figure out exactly what that level should be. And then each database and application will have slightly different requirements for the right way to set it up and leverage the pool. So for instance, in SQL Server connection pooling, this is something that you would do in .NET in code. So in all cases, the testing is paramount to ensure really that connection pooling is properly established and working as designed under load. This is also one of the importances of making sure that you live test applications under a proper amount of load rather than just locally. Okay, so data compression and data lock-in. So again, most applications are data driven these days. It is very, very important to make sure that if your application uses a data source, make sure that if you are spreading across multiple layers, you have the ability to lock records in the database when they are having transactions executed upon them. Your inability to do that within an application can cause corruption. It can also cause a number of consistency issues as well within the data set, and that can lead to big problems pretty quickly. So make sure that data lock-in, as well as making sure that you have appropriate backups and checking the consistency of those backups is something that is in place as well. Okay, so asynchronous programming. So this is something that is very much in the programming world rather than directly within the infrastructure world, but it's still very important. So if you're not the developer of your application or you are not responsible for this, then please make sure that your developers are aware of this practice. Most developers do this pretty well. So when an application calls a remote service that leverages a synchronous call, some of those resources on the client are blocked and are made unavailable for use elsewhere until the remote service invocation is completed. So what that means fundamentally is, in a web application, for instance, if you log into a website and that uses an API to connect to a third party or an internal service to validate your credentials, until that remote tool comes back with a response, that thread is practically unavailable. You will not be able to click anywhere else on the UI. You will not be able to process any other lines of code until that call has come back. So that pattern is very simple, but it is very, very inefficient. So asynchronous programming is the alternative approach, which would enable your remote services to be executed without waiting and blocking resources on the client. This is a really critical pattern for enabling cloud scalable software. Most modern programming languages and platforms will include the ability to do this. There's many different ways to do it. If we're talking about C# and .NET, then the async await pattern is where you need to be looking, and there are many different samples on the internet, along with different tasks and event-based asynchronous patterns. So that is definitely something to be having a look at. Microservices is also on here. We've talked about microservices and session affinity quite a bit already, but just to recap, that microservices or domain-driven design is a way of segmenting out the operations of your application in such a way that means that each layer of the application is responsible for something very specific. That makes it highly scalable and in many cases easier to manage and easier to diagnose faults. So those things, as well as session affinity, to really enable horizontal scalability and avoid the designing of web applications, like we were saying, that assumes requests have instance affinity. Make sure that those are key parts of your application design going forward. Okay, so on to monitoring. Okay, so let's just take a little step back a second, I guess, and what are the reasons for scaling? What is the goal that we're trying to achieve? And once we understand that, what metrics can we use to scale? What is the best practice for monitoring scalability? Okay, so some of the reasons for setting up auto scaling, they differ throughout different organizations, but I think you can commonly put them into 4 areas, okay? So the first one is, are systems able to handle the number of current requests? It's pretty simple. But actually, this is probably the most common one. Can your system maintain the current level of performance with this number of requests? If not, then you need to scale. Okay. Is there an opportunity to have cost savings by not over provisioning resources? So this is, the other way around. Auto scaling can be used to scale down when we are not using as many resources. We will save money in a cloud model, and over provision resources will sit there doing nothing. So it makes sense to scale down wherever possible. There's a number of other areas that we could look at in here. So when it comes to resources, so this kind of backs up our systems available to handle the current number of requests. So are the systems out of resources? So I'm talking about CPU, memory, I/O. If you're working with Azure SQL databases, in the older provisioning model, you might be looking at DTUs, database transaction units. Do you have enough DTUs to be able to serve the number of connections that you need? These are all things that we need to look at really and really consider. So what is the goal of auto scaling? So we've talked about scale up, we've just talked about scale down to meet current demand. So don't forget that scaling up is not the only option that we have here. Scaling down is also a very important part of this process that we need to be thinking about, and we need to be really aware of from a monitoring perspective. As we just said, we can decrease costs when scaling down when those resources are not needed. And we can also improve customer experience. So don't forget, the goal of this is to keep our services running efficiently in a performant manner. So we can improve customer service by offering uninterrupted service even when the demand peaks and troughs. So what metrics can we then use to scale? So as we said before, most Azure services offer the ability to export logs and metrics to services such as Log Analytics. Also external services as well, like Splunk, we can do that through Azure Event Hubs. You can also leverage technologies on the application side and the code level side, such as application insights, to get more the detailed level of telemetry out of there as well. Metrics come out of Azure services. They may include various different things such as CPU, memory, utilization, bandwidth information, storage information, and many, many more things. And it depends on the service. So those are all scenarios where we would need those bits of data to be able to look at those best practices for monitoring. So we need to know the minimum number of instances that should run at any given time. Sometimes that might be one, sometimes that might be two. So who knows? It depends on the application. So we need to figure out a baseline for our application. What does normal look like for our application? We cannot understand what normal looks like without collecting monitoring information. This is why it is so important that monitoring information is set up at the beginning and before anything else is done in terms of putting that application live. Normal operations with no users lets us establish a baseline. We can then establish further baselines with normal usage on top, which would let us then determine that, yes, the application is busy, but instead of using 1% while it's flat doing nothing, over the past month, we've established that normal operations take that to 12%, and we can use that as our baseline to go on and go forth. So it's really important to understand that information. You also need to determine what metrics are best for your specific solution to base your auto-scaling rules. So once you've established that baseline, you need to know which of those metrics are the ones that you will then trigger auto-scaling events. You can then go off and configure auto-scaling rules on those services that include it, or you can create alert rules for services that need to be scaled manually. Make sure that you monitor your web applications as well using App Insights, as we just said. App Insights provides a huge amount of data via instrumentation that can be added to code to make sure that we can understand exactly what is going on with our applications and when. That is something that is really important. Okay, so architecting for availability. So architecting for availability, we've talked about performance. We talked about making sure it is as performant as possible. Now it's time to look at making sure the application is reliable and available. Sorry about that. Siri decided to come in there. So reliability. It's actually something really basic to start with. You need to define requirements, okay? What do we mean by define requirements? You may think, well, we've built a system, of course we've defined requirements. But what are the requirements when it comes to availability? You need to make sure that you understand how the business is going to interact with the platform, interact with the system, when it can be down, when it cannot be down for planned maintenance and those sorts of things. And also, where is this application going to be used? Do we need to put multiple instances in multiple regions in Azure, or do we need to put multiple instances in one region to cater for local failures? In the case of a local failure, do we need to fail over to another data center in the same geography? These are all questions that need to be defined as requirements to make sure that we understand as architects, engineers, and operations teams how to keep that application up and running and what is expected of that application when something does go wrong. To answer all of those questions, you can use all of the architectural best practices. We've discussed a few of them already. I have a link to the Azure documentation that has a whole bunch more. I think there's 30 something of them, where you can go off and understand some of the cloud architecture patterns that you can use to really go off and figure out some more information about these and see which ones work with your applications. Again, something that sounds really straightforward, but is often overlooked: test your reliability. So I'm talking about implementing those disaster recovery plans, those failover plans for applications, and never testing them until it's too late. When you need to execute those plans and they don't work, make sure that you periodically test failover and also periodically test failback as well. It's really important that you test failing back to your primary instance if that's the pattern that you've gone for. Next one is deploy consistently. So Microsoft have a templating language available, which is called Azure Resource Manager. You can also use things like Terraform. Make sure that you use those tools to your environment to ensure that you deploy your resources consistently. Configuration errors are one of the #1 causes of downtime in IT in various different organizations. So make sure you deploy them consistently across multiple instances and multiple geographies to make sure that the application experience is not only the same, but that consistency will introduce a higher level of availability as well. Okay, monitor the application health. Again, sounds really simple, but make sure you understand and monitor what is happening with your application. If you don't know there's a problem, you will not be able to do anything about it and maintain that level of availability. Monitoring is really key. We also need to understand how to respond to failures and also how to respond to certain disasters that happen in our environments and our applications as well. So we talked about a couple of these earlier on, and some of these really are exactly the same. They share a lot of the patterns across the various different tools that we've talked about and the various different services. But we need to make sure that we understand the services requirements. We then need to make sure that we evaluate those requirements against the Azure subscription service limits. Make sure we can deploy our service efficiently within one subscription, or we may need to split it out into multiple subscriptions, or we may need to come up with an alternative approach. I would highly doubt many applications would fit into that, but it's something that you need to be aware of and something that you need to cater for. So make sure that it is one of the things on your list to think about. Implement resiliency patterns as well. So wherever remote operations exist, where appropriate, if your application depends on communication between remote services, follow certain design patterns for dealing with transient issues. So lost remote procedure calls, delays in receiving messages back from service buses, all of those things are all things that we need to cater for when we implement resiliency patterns. Any application that makes a call outside of the local environment is susceptible to a transient failure. So make sure that it is something that you understand what can happen on an application level and design to deal with those should they happen. A transient failure should not cause your application to be unavailable. So make sure those are dealt with effectively. Okay, isolate critical resources. So generally speaking, failures in one subsystem within your application can then sometimes cascade, resulting in failures in other parts of the application. That can happen when a failure prevents resources such as threads or sockets from being freed, leading to resource exhaustion. So sometimes in older versions of Windows, we used to run out of ports periodically, depending on what you were running. This is something that a lot of IT admins I know used to come up with against all the time. So to avoid this, partition the system into different isolated groups so that a failure in one partition does not bring down the entire system. This is called a bulkhead design pattern, where, for instance, you may partition a database, for example, by tenant, if you're a multi-tenanted application, and assign a separate pool of web instances for each of those partitions. You may also use containers to deal with this as well, to limit the resources available to a specific subsystem as well. We've talked about planning for usage patterns as well. And just to recap on that, that's where we make sure that we understand the application, we understand when the business is expecting more demand. So we need to make sure that resources are there so we can deal with that demand. Okay, failure analysis as well. So this is going into the service management world a little bit, but it's also really, really important. So failure mode analysis, or FMA as it's called for short, it is actually shortened to FMA sometimes, builds resiliency into a system by identifying the possible failure points and defining how the application would respond to those failures. So failure mode analysis should be part of the architecture and design phase, generally speaking. So recovery is built into the system from the beginning. So the goal of FMA is really to determine what types of failures an application might experience and how the application will go off and detect those failures, capture the potential effects of each of those failures and determine how the application responds, and plan on how you log and monitor the failure and identification of recovery strategies attached to those as well. So it's really important. And then if you need to, we've already talked about operating in multiple regions. Make sure that if your application is deployed to a single region, in the rare event that that single region becomes entirely unavailable, your application will also be unavailable. That may be unacceptable as far as your application is concerned, so consider if deploying the application and its services across multiple regions would benefit you. This could be in an active pattern, it could be in a warm pattern as well, but that's something to think about that is really important. So just a quick note on chaos engineering. So this is something that Netflix have come up with. So the Chaos Monkey engine that some of you may know about from reading on the internet. So chaos engineering is a methodology within software engineering that would enable developers to attain consistent reliability, basically by hardening those services against failures in production. So a common way to introduce chaos is by deliberately injecting faults that cause system components to fail. So the goal of this is then to observe, monitor, respond to, and improve your system's reliability under these circumstances. Some of the principles around chaos engineering are aimed at really increasing that service's resiliency. So by conducting experiments in a controlled environment, you can identify issues during development and deployment all the way up to live. The key things really are about being proactive, embracing failure. Failure should not be seen as a negative. It's okay to break the system, identify and address single points of failure early, instill guardrails and also graceful mitigations, minimize the blast radius, and also build immunity. So there's some quite heavy terms in there really. So what do we mean by things like blast radius? So stop the experiment when it goes beyond scope. Every experiment in chaos engineering should have a scope. An expected outcome of that experiment is unknown results. So strive to achieve balance between collecting substantial result data while affecting as few production users as possible. We talked about the bulkhead pattern a little bit earlier on. The bulkhead pattern practices that principle. So if something in one bubble breaks, that does not bleed into other separate bubbles. The overall methodology is quite simple, really. You start with a hypothesis, you measure the baseline behavior, you inject a fault or a series of faults, measure the resulting behavior, document the process and any observations you need to make, and identify and act on the results. You then need to validate the architecture choices, the process, and the code to make sure that you are on top of all of these things. Okay, so planning for disasters. So monitoring is really a key part of all of this, really. And when we're monitoring, we should be looking at things like early warning systems, remote call statistics, long-running process failures, and all of the other things that you can see on screen there. So what do we mean when we say an early warning system? So we should monitor our applications for warning signs that something is about to go wrong. This would enable us to have some proactive intervention that would stop the application from going down. There's a number of tools available on the market to do that. You can set thresholds at levels that identify issues before they become critical and require a recovery response. You can also send an alert to your operations team when that threshold value is reached, and they can do something about it. Remote call statistics. So we've talked about remote calls a couple of times, but in this instance, we mean the tracking and reporting of remote call statistics in as real time as possible and providing an easy way to review that information so that the operations team has a view into the health of the application. You can summarize latency, throughput, and errors in the 99th and 95th percentile, generally speaking, so that when those numbers change, we can see that something is going wrong and we can react as much as possible. That may even be a sign that is in the early warning system. Okay, so long-running processes. So when there are multiple steps in those long-running workflows or processes, each step should be independent so that if something does fail, we are able to track the progress and minimize the likelihood that the entire workflow would need to be rolled back or that multiple compensating transactions would need to be executed to return back to the original state. Okay, monitor your subscription and service limits. We've talked about this a couple of times already. It's okay understanding what they are, but make sure that you have a way to be able to monitor them. If you can monitor them, then you can catch any issues early, especially if you are doing automated deployments through a CI or a CD pipeline, for instance, where you don't always think about these things. Make sure that your monitoring is robust to pick up anything that happens along that chain of events all the way into production. Okay, so disaster recovery. We've talked about these a few times, but generally speaking, we need to be thinking about the reduced functionality of your application during anything that may happen in a disaster recovery scenario. So generally speaking, it's acceptable for some applications to be unavailable or partly available with some reduced functionality maybe, or there may be some delayed processing for a period of time. However, there are some applications where that reduced functionality is unacceptable. So you should make sure that you plan for things like network outages. When there's a network outage in Azure, when some parts of the Azure network are inaccessible, your application might not be able to access any data. In that situation, we need to design a disaster recovery strategy that allows most of our applications to run with reduced functionality. If reduced functionality isn't an option, we need to look at failing over to a different region. So we need to think about DR planning. Exactly the same with data. Think about data corruption and restoration of that data should you need to. The ability really to fundamentally understand the intricacies of your application and that application's relationship with your business results in an appropriate DR plan being implemented and executed when needed. That means that business can carry on in the event of a disaster. IT plays a fundamental part in disaster recovery, making sure that those really key business critical systems are running in the event of a business emergency. And there are a number of different tools such as Azure Site Recovery, different architecture patterns such as multi-tiered disaster recovery, such as the ability to back up and restore individual VMs and pieces of data. Also the ability to implement active passive warm spares and hot spares active. And then finally making sure that you test that failover and failback. We talked about it earlier, but I want to reiterate how important that is. When there's region-wide disruptions, make sure you take into account things like load balancing. So we can balance traffic across regions with a traffic management solution. So for web applications, we can use Azure Traffic Manager. And we can also take advantage of a number of third-party services that perform very similar functions as well. But resource management's a key thing. When you distribute instances across regions, creating separate cloud services in each target region, publishing the application package to each cloud service, something that we would do to make sure that all of the application code is there. However, distributing traffic across different cloud services in different regions needs to be implemented by the developer or using the traffic management service, as we've just talked about. Determining the number of spare role instances to deploy in advanced disaster recovery is an important aspect of capacity planning. A lot of people think capacity planning is not important when it comes to the cloud, but don't forget when an Azure data center becomes unavailable for whatever reason that is, there's also every other customer in that data center that wants some resources as well. Having a full-scale secondary deployment ensures that capacity is already available when it's needed. However, that would effectively double the cost. A common pattern is to have a small secondary deployment, just large enough to run those critical services. It's a good idea because it both reserves capacity in that region and it allows for testing of the secondary environment without affecting production as well. So Microsoft have introduced a way that you can look at all of this, and it's called the Azure Well Architected Framework. So I have a link at the end again, which I will load up, and you are able to look across cost optimization, operational excellence, performance, reliability, and security to make sure that you answer a number of questions based on the survey and you come out with a score at the end and things that you can do to improve your score. It is well worth running this. It's free. You can sign in and save your results, and I would highly recommend going off and doing this. It allows you to look at a specific application, your cloud footprint as a whole. It really gives you a really good idea as to exactly where it is that you need to be focusing efforts to improve what you are doing in those 5 areas. So that is something that is really important. So all of the things that we've actually talked about in here, just to summarize in some key takeaways, are all coming down to considering cost, operations, performance, reliability, and security as one. Okay, so all are equally important. Put as much equal emphasis on all of them as possible. Don't think about them separately. And also make sure that you understand your business requirements. A lot of the problems I see with clients' architectures and things that they've deployed and application estates is all down to the fact that they have not looked at the business requirements for that application. It's really important to make sure that you understand those business requirements in full as much as possible. Okay, so I'll leave the links up there for a little while if anyone wants to take a screen grab of those, but there's information in there about the architecture patterns we've mentioned, the architecture framework, and then there's also the assessment tool in there as well. And if anyone wants to reach out and discuss anything, by all means, you can get to me on LinkedIn. There's also my blog on there as well, and I'm a fairly active Twitter user. You can also find me on there. So with that, I'd like to thank you all for joining me for this session. Hope you enjoy the rest of the day. And as I've said, if anyone has any questions, then please feel free to reach out.
Awesome session by Martin. If you have any questions, please put them into the chat. We can try and do our best to answer them, but you can also reach out to Martin on Twitter and let him know if you've got any questions. I am just trying to get this to go into present mode, which is refusing to do. But just another reminder, if you haven't already, please scan the QR code that you see in front of you on the screen or go to the link. You will get access to Microsoft materials relevant to all the sessions that we've delivered today. So great chance to get some learning materials there, but also we feed back the information to Microsoft. So we'd really like it if you could give the QR code a quick scan. And we're going to take a break now for lunch. So we're going to come back at 3 p.m. for our next session. And our next session will be delivered by Sasha Kovacevic, if I've said his name right. If I've not, sorry. Sasha is a cloud solutions architect at Microsoft, and he's going to take us through security and compliance. Also just want to quickly mention that for our wrap-up today, so our wrap-up is at 5:15, we are going to jump into a Teams call, and we would invite the community to join us. So jump into that Teams call with the rest of the Cloud Lunch and Learn team, and we can wrap up, do some announcements, let you know about the next steps for the next part of the Ideathon, and we can turn our cameras on and take a group shot. That's Hugo's idea. He's obsessed with using the new Together Mode version to take a photo on Teams. So we need some more people to join so we can test out that feature.
Test the limits of Teams.
Yeah, exactly. So, Zhao, do we have any questions that we want to go through before we sign off for lunch?
We had one here from Andrew, but he said Martin already answered that the last bit of the video, which was something along the lines to how does he follow the guidelines he covered, and like the overall points. Oh, and then there was another, I think, before around IoT, which was, where is it? But so latency requirements for an IoT application. So I guess on that side of thing, it depends on business requirements. I would say you might have a bunch of approaches for IoT. You might have a device that is working and doing a lot of computational at a specific place that doesn't need constant communication. So that would be, it would be sending that information in batches, so you don't really matter much about latency. But if you're talking about Evelyn's project, where it might be for medical and people with needs, I think you should see it should be like as minimal as possible, so as real time as possible. Again, it all depends on the business and the requirements. So then,
so I think like you said, it depends on what kind of data is being passed. The app is asking the resources to do and how often it needs to access them. And I think, like you said, in an app like this, you want to be you want to have the latency as minimal as possible. We could always put a tweet out to the community and just ask sort of like a wide open question of like, when they think about an IoT app, what do they think might impact latency requirements, or what kind of things should be considered. We could always do that and see what people come back with, because people are always happy to jump on Twitter and help and offer up thoughts and ideas. We could always do that as well. Any other questions?
No, I don't think so. Okay, there's one about where is the Azure well-architected framework. So we can post a link.
Yes, we can do that.
There.
Yep, we can absolutely do that. I might share some links to some blogs as well that are in the community on the well-architected framework, because there's quite a lot out there that's good.
The documents are really amazing. It's actually my go-to documentation when I start a new project. I need to design a new solution. It really helps you to cover a lot of things, and design the best solution for the customer. And again, like Martin said, always depends on business requirements and the customer. So you kind of like have to have a pragmatic approach, because you can give them like the best design ever in business continuity and high availability and everything, but then they just said like, we don't have the money for it, so we can't have it on a secondary region, for example.
Yeah. So you need to match those requirements to the customer's budget, but also to their specific workloads, and maybe tailor the the solution for the specific workloads and their availability requirements. And also, it's good to start with a template for these things, right? So the well-architected framework helps you there. You're not starting with a blank page. You can work your way through, which is always helpful.
Yeah, it's really good. Like, covers a lot of the 5 pillars that Martin was saying. You do have examples for the different design patterns in cloud architectures. So yeah, it's definitely a good place to be and to look at. Either you're a developer or an architect. Like, you can't go wrong with it.
Yeah. Useful to everyone, I think. Okay, cool. We are going to take a break for lunch. So we'll be back at 3 p.m. covering security and compliance. And just a little reminder that for the wrap up today, we're actually going to jump into a Teams call. So all the Cloud Lunch and Learn team, and we invite you guys to join us. There'll be some tweets out around about 45 minutes before we're going to do the wrap up, which is at 5:15, with the links to the Teams event. But if you want it in advance, just DM us on Twitter or give us a shout in the chats and we can paste the link in there. It would be awesome if you guys could join us, and so that Hugo can test out the together mode and we can all take a photo. Okay, guys. Well, thank you so much for joining us throughout this morning. Great to have you here. Hope to see you after lunch.
All right. See you, everyone.
See you later.